Let me first start by welcoming everybody. Thank you for registering for this informal session. It is not a webinar. We are not trying to sell anything over here. We are just trying to explore this intriguing topic, which I found was very new and we don't know much about it. So let me first introduce me briefly. My name is Ajinkya Kelkar. I am director in Innovation Filter Systems and Transor India, and we make fluid filtration solutions in these companies. And now my very good friend, Mr. Aneesh Padalkar, who is currently in the US, he is the expert speaker today. Let me introduce him. So Anish has been working in automotive industry specifically in the last 15 years across various functions in engineering, corporate strategy, business development, purchasing, finance. And currently he is working as a director, Automotive Partnerships in Chargepoint. It's the largest EV charging solutions company in North America. He engages with automotive OEMs to ensure an enhanced and seamless EV charging user experience. Prior to this company, he worked as a principal in Ricardo, which was a strategy and engineering consultancy. And Anish headed EV-related business development and consulting engagements for automotive OEMs, suppliers, and government organizations. He and his team advised industry executives and policymakers on emerging technology roadmaps, market growth strategy, mergers and acquisitions, and procurement strategy. At ZF Group, an automotive supplier, Anish led software development teams for vehicle control systems. He is also a frequent speaker at industry conferences. Anish received his MBA and Masters in automotive engineering from University of Michigan in Ann Arbor. He grew up in Pune, India, where he completed his bachelor's in mechanical engineering. I would also like to mention that his wife recently published a very good book called Moramba. It's a children's book. I have read it. My daughter extremely loved it. So anyone of you who is interested, who has little kids, I would definitely recommend to buy that book from Amazon.
That's probably a more interesting topic than this one.
Yeah, I'll schedule another call for her then. So yeah, Anish, can you just start the conversation with telling us what Chargepoint does actually?
Yeah. Thanks for the introduction. We'll keep this very informal and as a chat. We don't need to get into any formalities or anything. So Chargepoint specifically. So Chargepoint is very specifically the largest charging solutions provider in North America and growing in Europe. I'll quickly explain some of the nuances in charging solutions and this kind of plays into how EVs may evolve in India and across various regions. So there are several business models within charging. So there are some companies who manufacture hardware for charging. You'll see specifically AC charging, fast charging, DC, etc. There are some companies that form the software layer to connect to those charging stations for access to users and also understanding over the cloud, repair, maintenance, all those things. There are some companies who own and operate those charging stations. That business model is fundamentally critical and very aligned to how EVs may grow over time. And that model is some of the infrastructural investment, especially for DC fast charging, is quite expensive. So when a company owns and operates stations, it's a significant investment for them to put up front. And the way they try to recover that is through charging the driver electricity. So input of electricity, markup, sell of electricity. That's fundamentally the only business structure that recoups the initial investment. So naturally, the number of EVs on the road and the utilization of the stations is critical for the station operator and owner so that they can recover the cost.
Yeah.
So it's kind of a chicken and the egg problem where growth on EVs will give rise to growth of charging stations and vice versa.
Okay.
We'll get into specifics of how and why some countries have more penetration of EVs versus some others, but as kind of an overall structure. Chargepoint specifically is a very asset-light company, and I won't get into the specifics of Chargepoint because that's not really relevant to the conversation. But the difference in business models is quite important. So, a company like Chargepoint makes hardware, software solutions, etc., sells both hardware and software to site hosts who own stations, put them on the ground.
Okay.
But fundamentally, the challenge of profitability still remains exactly the same. The more EVs on the road, the better it is for charging providers and site hosts who own those stations. And it's very much back to the chicken and the egg problem where both will kind of grow together.
Okay. So, since we are on the topic of growth of EVs, so I think the most relevant question right now would be, what is the current scale of EV adoption? I mean, where are we right now? We in the sense globally and in India.
Sure. So let's maybe start with why are EVs gaining so much attention across the globe? Is the attention valid, relevant? And then we can get into some of the specifics of how projections in India will, line over the time. So a lot of noise around whether EVs will be mainstream. Why are EVs so interesting? Quite simply, the OEMs who are investing, it's most of the OEMs, by the way, globally, including, General Motors just announced that by 2035, they will produce only electric vehicles. And if you take the normal life cycle of vehicle production from design to launch, it's usually 3 to 5 years, which means that you backtrack the last IC engine that General Motors will design or the suppliers will produce comes somewhere between around 2030, 2031 to 10 years away. So that's a big company like General Motors announcing that is a huge deal, which makes all of us think about why is this relevant.
Yeah.
And quite simply, the projection is from a technological standpoint, the cost of EVs, and if you narrow it down further, the cost of battery cells, packs, and then the power electronics, gearbox that goes along with it, the electric powertrain, that cost fundamentally over time will be cheaper than the equivalent IC engine and powertrain. That's the fundamental technological assumption that everybody who's investing in this space is working toward. Whether that will happen
is the hope.
Yeah, that's certainly the goal.
Okay.
But you can get some indicators as to the companies that are essentially putting all of their eggs in the EV basket, which is most of them these days. So that's the technological assumption over time that will happen. Now, if that happens, then what are the other enablers? So the traditional business model of an automotive OEM historically has been make cars, and then sell service parts. Okay. That's it. That's fundamentally the business model. Yeah. That is being challenged by many other companies with a variety of different business models, ride hailing, for example, or in recent cases, connectivity, autonomous technology. That's not as relevant in India, but it is relevant in other countries. That is making OEMs think, how can I grow my revenue models? So electric vehicles fundamentally are enablers to some of the other business models. Why? Because now you have higher power available on board to enable connectivity, autonomous technology, etc. That's one of the reasons, not the main, one of the reasons that connectivity then enables other business models. So ride hailing, autonomous technology is further away. It's not as relevant yet. But because electric vehicles enable these opportunities, and the technological assumption is that electric vehicles will be cheaper than comparable gasoline and diesel vehicles, it is attractive for OEMs to invest money and divert attention towards different business models. So it's not specifically electric vehicles are interesting, it is how can I grow my business model opportunities? And electric vehicles are one enabler to do that. That fundamentally, a gasoline or diesel vehicle has limitations to.
Correct.
So that's the overlying picture. Now,
So if I understand correctly, what you're saying is a petrol or a diesel engine can't be autonomous, or there are more challenges in making that autonomous than EVs.
yeah, I wouldn't want to stress too much on autonomous technology because that's so far away.
Not the autonomous part, but I mean, you gave the example of autonomous.
Yeah.
enablers
So for
of
argument's
autonomous.
sake, let's talk about autonomous technology. It's not as relevant, but let's just argue for a second. So it's not that gasoline or diesel vehicles can't be autonomous. There's no technological barrier to do that. The question always is, what can you produce in limited resources? What are the limited resources? The limited resources are how much energy power do you have on board for processing data. So connectivity, for example, where you connect with the cloud and interchange data very frequently, how can you do that with limited cost on board?
Okay.
So you will need to have power on board to do that. If that comes in form of a battery that is then technologically superior, which can pack a lot of power in limited space, that lithium ion or another technology can provide, then that becomes very attractive from a cost efficiency standpoint to put on board versus having an engine that you then need to append with some other power source for connectivity. So that's the assumption is that we'll move to a vehicle that has many applications, not just individual driver experience, but shared mobility, et cetera, that's causing OEMs to rethink where can they change the technology on board. So all of what I've said is not as relevant in India yet, but that's the reason why electric vehicles are gaining momentum in other countries that will maybe trickle down to India in due course.
Correct. So if I have to sort of reiterate what you just said, so can there ever be a scenario where all the cars sold across, I mean, anywhere across the world, can all the cars be EVs? Can that ever be a scenario?
Yeah, so let's unpack that for a second. Hopefully you can see my screen. Yes? Yeah, you can see my screen?
Yeah, we can.
Okay, good. All right, so this is only passenger vehicle. This is, Bloomberg NEF, quite reputed. They put out EV forecast every year. Take it with a grain of salt. Nobody really knows the future. All of that is relevant. So the numbers here, I don't want to focus specifically on the precise numbers, but there's a story here. What is the story? The story is that there is a specific growth trajectory that every country historically has followed for EV penetration. So this is 2015, so 6 years ago, and kind of the state of play as to how EV adoption has evolved in specific countries. India is much lower, as we all know. Penetration is still less than 1% of total vehicle sales across the board. Two-wheelers, three-wheelers, pass car, trucks, anything. It's below 1%. I should outline that very specifically, that in my view, this is not a race. This is just a current state of play, but it's important to know how the trajectories flow, and more so, why and what is causing this difference amongst countries, and why is China leading, not leading the race per se, but leading in terms of electric vehicle penetration. Why is it occurring in China? Why then in Europe? Why is US, relatively speaking, lagging? And why is India just getting started? What are the reasons behind this? I will focus less on the numbers, more on the reasons that's causing this. And if you kind of portray this over the next 20 odd years, this is the snapshot. So again, this is just four-wheelers, so passenger vehicles. So the story for two-wheelers, three-wheelers will be slightly different. Will be more penetration in those segments, but kind of the relative scale is still relevant. So, for example, if you kind of take a snapshot here, 2030, you're looking at less than 10% penetration in India. By 2040, you're looking at roughly 30% penetration, give or take, put a margin around it, and you kind of get a picture of what's happening. Now, again, the two-wheeler, three-wheeler segment, you'll see higher penetration, but that's the scenario. The question was specifically, will there be a scenario in the future where all vehicle sales will be electric vehicles? Well, I mean, maybe, but this, by the way, my experience with Bloomberg is this is quite an aggressive forecast, generally speaking. And even with this aggressive forecast, over the next 20 years, even Bloomberg is not saying China will have 100% EV penetration. So it's difficult to imagine a future where only electric vehicles are sold purely across all regions globally. If that will that happen, who knows? There's a reasonable chance, though, that China, Europe, US, which are kind of in that order, higher penetration of EVs, will have a majority. So majority meaning more than 50% of new vehicle sales as electric vehicles over the next, if you take a snapshot in 2040, they probably will have crossed that barrier of half the vehicles, new vehicle sales will be electric vehicles. India is further behind, and get into specific reasons why that is happening. Is there an advantage? Is there a disadvantage, etc.? But that's kind of the current snapshot.
And so, I mean, the graph tells a pretty compelling story, as you said. China, as we can see, it is way ahead, and still it will grow further. And India will probably by in the next 20 years will reach somewhere where maybe China is today. So, I mean, like you said, the reasons behind the story are more important. So are there any roadblocks in achieving this, or why
Sure.
is this, why it is 20 years and not, let's say, 5 years or 10 years? What is
Sure.
stopping the countries?
Sure, yeah. So let's unpack some of the reasons, because the reasons are more important always than the numbers. The numbers, projections are just projections. Those could be wrong. The reason as to what's causing this projection is important. So let's take China as an example, because there's no question they are leading in terms of electric vehicle penetration compared to any other country in the world by a margin. So why is that happening? And the simple reason is that government subsidies starting from about 10 to 15 years ago has helped the penetration. So what does that specifically mean? There are, let's say, three verticals. One is, battery cell production, and in that same vertical you put battery packs, so cell and pack together, so supplier. And then you have, in that same vertical, you have the power electronics, so motor, inverter, DC-DC converter, onboard charger, gearbox. All of those reside in that one vertical. So cost of manufacturing for electric powertrain, that's one. The second vertical is OEM, who will own the vehicle and then sell it. And the third vertical is charging. So China has fundamentally subsidized all those verticals, and is the only country that has subsidized all those verticals. So not surprisingly, for any new technology, the cost is high. And if you want to make a compelling case for the user to buy a new technology that is more expensive than any existing technology, somebody needs to subsidize it. And the obvious answer is the government needs to subsidize it. So China has taken a very specific stance a long time ago to subsidize many of these, all of these three verticals. The other critical notion is China has part ownership. The government has part, this is not news to anybody. So China has part ownership into companies that operate in China. That's just the fundamental business structure. So the government usually is in some ways is heavily tied to these, to the companies. This is fundamentally different than how Europe is structured, of course.
Yeah.
The reason why, and Europe will take, let's say, divide into two. One is, let's say, Nordic nations. So Norway, Sweden, Denmark, etc. And the other being, let's say, Central Europe, Germany, France, Spain, Italy, etc. Nordic nations the cost of gasoline is higher than most other countries. So compared to the US, it's like 3x. And US, let's say, cost of petrol in India, 100 rupees per liter, let's say, is slightly more expensive than even when you convert dollar to rupee. So India is more expensive compared to the US. The Nordic nations are way more, that's like 3x compared to the US. That's fundamentally then the operational cost of owning and using a gasoline or a diesel vehicle fundamentally changes. That's why you see, like, already in Sweden, 50% EV penetration.
Wow.
Why? Because fundamentally it's more expensive to operate a gasoline vehicle in Sweden because the cost of gasoline compared to owning electric vehicle, cost of operation is lower. So the reason why EVs have penetrated more in China is fundamentally government subsidies. The reason why EVs have penetrated in Nordic nations is fundamentally cost of gasoline. Some of the other nations in Europe are slightly lagging behind, not as much. And fundamentally it's because the government subsidies are not as aggressive as China's, and the cost of gasoline is not as high as the Nordic nations. And then the US, where cost of gasoline is very cheap, relatively speaking. So there is no compelling reason today for a user to switch from a gasoline vehicle to an electric vehicle so far. Now, that is changing, of course. But the reason why, let's say, the US buyers are buying electric vehicles it's fundamentally started with Tesla. And it was specifically not because Tesla is just an electric vehicle. Tesla offers, at least in the user's mind, something more, better than a conventional gasoline vehicle. And it's not just having electric powertrain. That's one of the reasons that you get instant torque and go fast, etc. That's only one reason. There are several other features that are attractive to Tesla buyers. And there is, let's say, a misconception that because Tesla is an electric vehicle company, it's, then any OEM that produces an electric vehicle will be as successful. Many attributes to buying a vehicle, and any buyer is not necessarily a fully rational buyer.
Correct.
So various reasons why different companies countries are where they are. In India, of course, the government subsidies are not as aggressive yet. The other reason that is somewhat important, not crucially important, but somewhat important, is China has a large portion of lithium reserves, or they have acquired access to lithium mines. Same is true of
lithium is, I think, the base material to make the battery.
Yeah, lithium ion, yeah. Not the only material, one of the materials. China also has access to the other critical rare earth metals for electric motors and so on and so forth. So nickel and cobalt are the other two. Now, cobalt is heavily available in Congo. China has access to that. There are controversies around how the manufacturing and the process goes on there. There are technological advancements to remove cobalt from batteries completely.
Okay.
Main storyline is China has been ahead of the game in terms of acquiring access to lithium. India doesn't have lithium reserves. At least, we haven't found those in India. There are recently, I think, a couple of years ago, there was some lithium reserves found in Karnataka. Still, compared to other countries, and the scale that is necessary, very minuscule. So India has to import lithium. India has ties with Bolivia, where there are lithium reserves. Import lithium. There's still import duty on on the raw material, on finished goods of battery cells, battery packs, electric powertrain components, fully assembled vehicles. There are still barriers to how India will become cost competitive, but that's kind of the landscape of generally, if you want to have electric vehicle penetration, you need to be government subsidy. That is starting to happen in India, and take some time.
Okay. So if we think of, you mentioned a rational buyer. So a buyer who buys or bases his decision purely on cost advantage. So in in any country, if there is no artificial support, so like subsidies or anything like that, uh, is there any cost advantage of ownership of electric vehicles for the consumers?
So that's a good question. So two things. First, matter of fact, no electric vehicle manufacturer in the world is profitable today. When you take into account purely accounting principles and you follow those, there isn't an automotive manufacturer who is net profitable on electric vehicles. That includes Tesla. So Tesla, in the last several quarters, has shown profitability. That profitability is fundamentally due to sale of ZEV credits. So in the US, I won't go and get into the details of it, but in the US, certain states have mandates to sell some number of electric vehicles. If you are unable to, like California, if you're unable to do so and you're a manufacturer selling those number of vehicles in that state, then you have to pay a penalty or buy ZEV credits, zero emission vehicle credits. Tesla sells zero emission vehicle credits to other OEMs. And if you look at their accounting, 10K over the last 4 quarters and how their accounting is structured, all of those profits come from ZEV credits in the last quarter sale of Bitcoin, but we won't get there. But fundamentally, there isn't an OEM who is profit yet. There will be, and that's the whole technological assumption is eventually electric vehicles will be cheaper. So that's one part of the equation. Second part of the equation, does it make economic sense to a buyer to buy an electric vehicle? It depends on subsidies.
Okay.
So in the US, there are subsidies for electric vehicle purchase. It's the same in China. China has the most aggressive subsidies. That's why you see penetration. It's because they take the burden on themselves and not put it on the buyer. So it's very simply a cost game. Who is willing to take the burden? And if the subsidies go away, electric vehicles today are still more expensive. Like for like, the electric powertrain is more expensive than the ICE powertrain.
Oh, okay.
That is still true. And eventually that will reach parity eventually in the next few years. The projection is roughly around 2025-ish, you will reach cost parity. Today, it's still expensive. So it depends how much you drive every day. And then how soon can you recover this premium by operational cost? Because roughly the equation is, it's about one third cheaper to own an electric vehicle operationally. Purely, if you compare, kilometers per liter equation.
Yeah.
Very simply, or kilometers per liter equivalent in case of electricity. Purely, if you were to take that comparison, it's about a third cheaper to operate an electric vehicle. Of course, then you have to balance how many kilometers you drive every day, and is the cost premium that you pay upfront. Quite simple equation. But today, fundamentally, no, it's not economic. You see, most of the buyers of electric vehicles are these early adopters who buy electric vehicles for other advantages. So economically, no, it's not. Today, it's not economical yet.
Okay.
Again, the caveat being how much subsidy is available. If the subsidy is high, yeah, of course, it's economical.
Okay. You mentioned something about the powertrain. So, my interest in this topic started because I saw an article and later I wrote a blog on that. That electric vehicles have 86% less machining, or the machined components required in the current IC engines are not there in the electric vehicles. So the current manufacturers or the manufacturing scenario, the people who are supplying to automotive industry primarily, do they, so is it like manufacturing as we know today is going to get disrupted because of the adoption of EV?
Yeah. So let's compare component for component, right? And understand what are the skills necessary to make those components. So quite simply, in engine, you have engine components, powertrain components, all of those, industry well aware. So you take that out and then you put electric powertrain in. So what are the specific components in electric powertrain? You have the cell, which is a very specialized skill set to produce high capex, etc. There are only a handful of cell manufacturers, and now growing, of course. But cell manufacturing is a highly technically complex area, and it's because one of the key reasons is it's a moving target. The chemistry is not fully defined yet. Like I said, there are efforts to get cobalt out, there are efforts to do solid state batteries, so on and so forth. So technologically, we haven't reached steady state for cells. That's one. That's a completely different skill set. Then you have battery packs, which is essentially cells. Many cells make a module, many modules make a pack. So assembly, so usually the cell manufacturer assembles those in modules. And then there's another step of how you assemble that in a battery pack that you can put in a compact space with a specific form factor. Now, if you take the traditional OEMs and say, as an OEM, historically, when there weren't any electric cars on the road, historically, how were OEMs differentiating themselves versus competition? One of the main, let's say, system was engine and powertrain.
Correct.
It was one of the key areas where OEMs differentiate themselves. So most of the OEMs have a very close, let's say, allegiance towards design, and in some cases assembly, not necessarily manufacturing all components, but design and assembly of engine and transmission. If you translate that to electric vehicles, now I'm an electric vehicle manufacturer, I want to differentiate myself versus the competition. What should I hold on to and what should I give out to suppliers? It comes back to like for like. You have the electric battery, the battery pack, and then the power electronics and the gearbox.
Yeah.
So like for like, this is the comparison. So as an OEM, most of what you will see, and there are partnerships already occurring between OEMs and cell manufacturers, that you need volume guarantees and so on and so forth. That equation is kind of already fixed. It's difficult to penetrate that value chain. Okay, so that's out of the equation. What else remains? Then you have motor, inverter, DC-DC converter, onboard charger, and gearbox, fundamentally, and then some other power electronics, junctions, ports, and so on and so forth, fuses and etc. But then if you go down the list of complexity, the gearbox is fundamentally kind of like to like, but electric vehicles will have 1 or 2 speed gearbox.
Okay.
Because the interaction of the battery and instantaneous torque means that you don't need multi-speed gearboxes in electric vehicles. So you now have a single speed or just a dual speed gearbox in an EV compared to multi-speed gearbox, manual or automatic gearboxes in the regular vehicles. So that's a like for like, but that's a much reduced size. Okay. So the number of components, of course, reduces. You take away the engine components completely, which require high precision machining, etc. Then you have the gearbox that is kind of like but much lower size. Then you look at the other components. You have the motor, inverter, and like I said, DC-DC converter, onboard charger. These are not new components. These have already applications in other industries and so on and so forth.
Correct.
The challenge always is, now that the rules of engagement are changing, you have all these components that the 4 or 5 I mentioned, and the question is fundamentally the same. How can I increase efficiency? How can I reduce weight? And how can I reduce cost? It's fundamentally the same questions. And there are, even in something as, let's say, steady state as electric motors. Electric motors have been, everybody's been using electric motors for decades. It's not a new component. Even there is tremendous R&D, tremendous investment, new motor companies coming online to find different ways to reduce these 3 variables that I talked about. Same goes for the other components. The nuance is, it's a different skill set. It doesn't translate directly from, if you're machining, a camshaft or a crankshaft or a cylinder head, that skill set doesn't translate directly to making these components. but you can have, you can still make subcomponents within these systems. So that's one. So that's on the production side. There is a whole different equation once the vehicle is out in the market. And then now you're looking at serviceability. And that opens up many other opportunities. So one of the underappreciated complexities of electric vehicle penetration is once you have the vehicle out on the road and something fails, like a cell fails, then the cost to replace that in today's structure anywhere in the world is still very expensive.
Oh.
And the number of, so now we're looking at other opportunities downstream. So now you're talking about, remanufacturing, refurbishing, recycling, and repurposing. That is a 4R. This is another industry that is developing very quickly, that is still very nascent. It's nascent here in the US by far. Not many companies do these. There are only a handful of companies, but it's not really glamorous. Glamour is on the upside. But this is a huge opportunity because the recycling equation of batteries has not been solved yet. What I mean has not been solved yet. Like, for example, disassembling a battery pack is a fundamentally complex process that is labor intensive, it is cost intensive. It depends fundamentally on how the battery is designed, whether it was designed for serviceability in the first place. Like, for example, there are OEMs and suppliers who, in many cases, there are various crude methodologies employed. That is, now we're getting into a refined state, but things like gluing two things together, bolting them on, or welding those together.
So gluing two cells or modules together to make a battery.
Yeah, modules. Yeah. Cells go into modules go into pack. So depending on how those are connected, there are different techniques, being deployed. So if you were to take those apart and you were to find a second life use for those batteries, that process is not consistent because it depends how it is designed.
Okay.
And the design is not frozen yet, right? We're still evolving in terms of what's the best chemistry, what's the best form factor, how is the best power density going to be formed, what are the best practices for assembling these battery packs. None of this is final anywhere in the world. So naturally, the downstream effect of recycling and second life use is not economical if I'm a business owner, because I need to work through many of these complexities to figure out how can I keep my costs down to have another use for these or recycle material. But that is a very underappreciated area where there is tremendous opportunity. But the nuance again is much different skill set compared to what companies would do today. But untapped, tremendous opportunity. The supply base generally in the world is, it's not refined. Cells are much complex. I would say, that is a different skill set. This, in terms of disassembling battery packs and then refurbishing them or repurposing them or recycling them or finding second use, unexplored generally, definitely much less explored in India, but having, it's a different skill set.
Okay. Yeah, I think that's a very something new business owners can, or other current business owners can definitely tap into. I think this opportunity of, I would say, servicing of these battery packs, or
it is. It's a heavy lift.
Okay.
Right? It's not a natural transition. The skill set required, the capex required, all of those things are fundamentally different.
Okay.
But there's opportunity.
Yeah.
And it goes back to what is going to be critical volume of electric vehicles, specifically in India, to then warrant this other supply chain being developed.
Correct.
That's why the penetration that we looked at by 2030 is still roughly looking at less than 10%. I mean, the goals of the country are much larger than that. There are these nuances from a cost competitiveness standpoint in the overall ecosystem, like not just the sale of electric vehicles, but then how do you support those once they're already on the road? That is, much less understood, but that will come to the fore soon. that will affect penetration. Because then if I'm a buyer of electric vehicle, my immediate hit is the residual value of my vehicle. If that drops significantly upon ownership, because the cost to do something with the vehicle once I stop owning it is high, naturally that cost then is passed on to me, as
Correct.
it means that my vehicle depreciates quicker than
Correct.
a gasoline vehicle. And you're seeing that already in some cases in other parts of the world. Tesla is a different equation entirely, but generally this is still unsolved.
Okay. Yeah, that's something very interesting. So, uh, regarding allied technologies, so we are aware of this battery technology being, obviously, that is at the core of electric vehicles. But with any new technology that comes up, generally it is seen that allied technologies get developed.
Yeah.
So maybe it is the charging infrastructure or the way the chargers are designed or something like that. So what are these allied technologies that are getting and will get developed in the near future as the scale of electric vehicles increase?
Yeah, so we briefly touched upon it, right? So it is fundamentally fairly straightforward, right? So it is, you have the, I see engine and powertrain, that gets replaced in terms of electric powertrain. You kind of covered that like for like. Then you have upstream opportunities for production. You have downstream opportunities once vehicles are on the road in terms of service.
Yeah.
And then separately, you have charging station, charging provider opportunity. But that's, again, this is fundamentally the complexity and the threat is that this is the skill set required to get into that business is fundamentally different than precision machining for engine or transmission components.
So when you say skill set, is it like a person having the skill set or the company in general having the uh, expertise?
Yeah. So I mean, use skill set very loosely, right? It is, anything can be gained over time with the right investment, with the right right lead time. Anything is possible. But so if I were to rank in terms of where is the immediate, what are the immediate adjacencies, and you say I would put battery cell and pack separate. That's specifically different skill set. But then you have power electronics, so gearbox is like for like, and then I would put all these others: motor, inverter, converter, onboard charger, as and components for those as an adjacent and immediately accessible in area where a manufacturer can go.
Okay. So when we generally, I mean, you discussed this earlier, and probably it was why this EV technology is getting adopted in the first place is because we think, or generally it is the media, what it shows is that it is a greener technology.
Yeah.
And I mean, people or at the early adopters are buying these cars because they want to have green mobility.
Yeah.
But in reality, but there are, like you mentioned earlier, there are some conspiracy theories around these as well.
Yeah.
Are EVs really green?
Yeah. So let's break this down. So the way I'm going to break this down is, again, 3 areas. One is production stage. The second is operation stage. The third is afterlife. So it's important we cover the whole life cycle. And of course, there are subsections within this, but let's, for simplicity, just take these 3 verticals into account. The first vertical is production. So, fact, the energy required to produce lithium-ion cells, modules, packs, general assembly, higher energy, higher than comparable. Now the question always becomes, what is your source for production? Is it coal-based or anything else, renewables? If you use the same source to produce these components, you're likely going to need higher energy for these components for electric vehicles. The operation stage is very clear. The energy required is much lower to operate electric vehicles than conventional vehicles. For now, I'm completely ignoring the source of electricity.
Yeah.
That's a separate topic. But just energy consumption. So in the first case, more energy required for electric vehicles. In the second vertical, less energy required for electric vehicles. Third is still unsolved because of because number two, in terms of design and how the battery packs are structured and what the second life use may be or may not be, recycling, all of that is still unsolved. So number three is still a question mark in terms of how this may evolve. Again, going back to the technological assumption, is that overall, in steady state, electric vehicles will be greener. That is still true. There are some kinks to be ironed out yet, and I'll bring in the source of electricity as another variable in here. So source of electricity that moves to generally renewable, that helps everybody, and that if a plant is using renewable energy, then regardless of whether using producing engine components with it or battery components with it, same. Yeah. So then it goes to the operational element. The operational element is clear. Electric vehicles will use less energy compared to conventional vehicles. And then if you solve the downstream notion of second life and recycling, that is still it's a question mark there. Then eventually electric vehicles. By the way, generally electric vehicles are greener, but I want to outline in what cases does this concept fall apart. And this is the structure. If you think about it, there's the three verticals. This is the structure in which, in some cases, maybe electric vehicles are not greener, but eventually over time, they will be.
So probably as a driver or the owner of the electric vehicle, I might be using a greener technology, but that doesn't mean that to make those cars, the technology used is green. I mean, we may be...
True, but that's why I want to separate out the source of electricity completely from the equation. Because the source of electricity is the same,
not in our control,
regardless of what you're making with it. The question is only about how much energy is consumed. And the energy consumption is in the manufacturing stage, it is in the operational stage, and then it's in the afterlife stage. So if you compare energy consumed, then yes, generally over time, in steady state, electric vehicles will consume less energy compared to conventional vehicles. Where it breaks down today is you don't have a refined steady state industry accepted recycling and second life use case.
Correct.
That's why you have all these lithium-ion batteries coming out, because we're still early days. The vehicles are not at the end of their life cycle. Once that happens here soon, and that happens at high volume, what do you do with those battery packs is a question that is becoming increasingly relevant, that is fundamentally not completely solved yet.
Okay. So now coming back to the question of adoption of EVs in India.
Yeah.
So Indian government, I think, mentioned that there should be some the number of EVs sold by 2030 or 35. They have put some number on it.
Yeah.
One, is it possible? And two, is there any grain of salt? Should we take it with a grain of salt?
Yeah, I mean, anything's possible.
Yeah, correct.
If you put the question becomes, how do you make it possible?
Correct.
It is possible. How do you make it possible? So the ways to make it possible is fundamentally, start with two things. One is, if you look at the competitive landscape globally and say, okay, forget about India as a country, you look at the global landscape and you're trying to look at, okay, where can I source the cheapest components from? it's no mystery that the cheapest components today are not available inside India.
Correct.
They're available elsewhere.
Correct.
So then the question becomes, can you source those at the cheapest cost, i.e., at zero duty?
Correct.
Today, the structure is that those components cannot be insourced into India at zero duty. There is some duty to get those in. In fact, I think in 2019, the government had relaxed duty structure for a period of time, and I think now it was until April 2021 where there was this lower duty structure in place. And I think now over the last month, I could be wrong on this specifically, but I'm giving pointers in terms of what to look for. In terms of possible. One of the pointers is what is the duty on these. I think the duties have gone up just recently. So that's one element. The second element is, okay, fine, if you have duties, then within India, how do you make cost competitive components available? So for that, again, it comes back to incentives, it comes back to subsidies, and so on and so forth. You attract, this is not new territory for the world. Everybody's been thinking about this for a while. There are companies established elsewhere in the world. They're already available, setting base up in India, so on and so forth. There are Indian manufacturers doing the same thing. So it comes back to how much subsidies is available. The structure as it stands today is not enough to reach 30% penetration by 2030.
Okay.
So if you go down the same path, then that's not enough. Whether it's possible, anything is possible. What do you do to make it possible? It's two things. One is, reduce duties and increase incentives. Of course, this is not an isolated problem, right? The government think about many other things and sources of revenue to subsidize many other economic complexities that we're all undergoing right now. Are electric vehicles really that important in the grand scheme of things? It's not up for us to decide. But those are the levers, let's say, you would pull to make this possible.
Okay. So I think there are some questions coming in now. We'll take them one by one. So Amar Gokhale is asking, do you think that the question of recycling all these batteries will ever realistically be solved? Or is it just a pipe dream? Given that the question of e-waste right now is not solved either, with most e-waste being recycled in the informal sector manually under hazardous circumstances in third world countries. Will this fantasy steady state ever be achieved?
Yeah, I mean, like I said, nobody can predict the future. But again, I want to focus less on whether, it'll be a state where 100% EVs will be sold in the market, but what are the factors? So yeah, right now it's not solved. It's right. It's an open question. We can't predict technological advancements.
Right.
That's the complexity that because there's investment being made in these areas to solve this problem. But you can take indication. What are the indicators? The indicator is that major manufacturers, OEMs, are committing to electric vehicles. So if you take that as an indication, that again, you go back to technological trajectory. The assumption is that at some state, you will be able to recycle. So by the way, recycling is technically not impossible. And finding second life use is technically not impossible. It's the cost that makes it a heavy lift for companies to stand on their own and do it. So if you were to reach a steady state where the design is standardized, the disassembly is standardized, and then you have manufacturing or recycling process. In fact, there are a few companies in India, I'll send it after this chat, that are already, so there's a separate industry by it will solve the exact same problem. Tremendous investment in this area to find innovative ways to break down and reuse the materials inside. It's not solved today. We can't predict whether it's going to be solved, but it's a critical driver to the success of EVs. But if you were to take indications from the market, yeah, I mean, it's the assumption is that we will reach that stage.
Okay. So next question is from Sanjot. Is it not straightforward for the existing manufacturers of inverter or converter or power electronics tech, etc., to transition into being a supplier for EVs in future? Is there a fundamental paradigm shift in production technology of these components that require when that that's required when they are used to be in that are to be used in the EVs? Adapting may be fine, but a paradigm shift, which means that the current skill set in these tech just cannot support when it comes to making the same components for EV. So she's asking that people who already make these components, do they need to do something different? Is there any change for these component manufacturers, so converters and power electronic manufacturers, for supplying to EVs?
Yeah, so of course, this is a technically loaded question. I explain it at least at a high level. So yes, people who make these components today, of course, will have an advantage. Again, the challenge always is the rules of engagement are not fixed. What I mean by that is go back to the three variables. How do I reduce cost? How do I reduce weight? How do I increase efficiency? That's fundamentally the question for everybody, and OEMs will continue to challenge suppliers and themselves to come up with a structure where we'll always try to optimize this equation. So the rules of engagement are not fixed. Why that is important? Because that then once the rules of engagement are not fixed for anything, it offers opportunities for other companies to come in and figure out innovative technologies. If the rules are even let's say oversimplifying the automotive industry, there are new car companies coming online to do the same thing. So of course there are advantages for companies who have, it's like studying for an exam, right? Whether you have 15 years of experience studying for that exam, or you have you're just starting to study today. The the nuance is the exam isn't today. It's an ongoing process, and if you look at electric vehicle penetration over the next 10 years in India, it's still roughly 10%. There's plenty of opportunity to learn and study for the exam. We're not even scratching the surface yet.
But there is no fundamentally different skill set required for these. So
yeah, that's right.
There is nothing different for EVs.
They have an advantage, yeah, for sure.
Aditya Rajderkar is asking, about 60 to 70% of world population is surveyed at being below middle class level.
Yeah.
And 7 countries are still categorized as developing. So how will EV OEMs and supporting industry make enough profit for long-term profitability into market apart from China, US, Europe, and some other limited focus markets?
Yeah, so I mean, I'd like to dig deeper into the question, and Aditya, if you can, ask question, if you can type, great, or if you can unmute, that's fine too. So if you break the market down, and Aditya, you will know this. This is like, where is the highest volume? As a business entity, I care about profits. I see that electric vehicles, at least my projection says that electric vehicles will be cheaper. If they're cheaper, then they'll be profitable. It opens up other business models for me. That's why they're attractive for me. In that state, when that happens, then the cheaper technology is more beneficial for market generally. So the starting point is, and you'll appreciate this, that where Tesla started was from the luxury segment, where people can afford the premium to pay for electric cars. Then you get volume, then you drive down cost based on volume, and once it becomes cheaper, then you expand it to the other lower segments. So from that standpoint, yes, I mean it's good. It'll take time to do that. That's why you see either it's government subsidies like China, or you have developed countries in Europe or North America who are the early adopters in this. And even within the US, and you'll know this, it's still the upper echelon who's buying electric vehicles. It's not a mass market vehicle yet. I mean, Ford, there's an announcement yesterday, 2 days ago, Ford, the highest selling electric, their gasoline vehicle, F-150 pickup truck, they converted that to an electric vehicle. In 48 hours, they have like 50,000 orders. But their
Wow.
price point is incredibly low. It's like industry leading low. But again, they're not going to make profit on it. So this is a long game. This is, it's going to take time for the components to reach cost parity, and then for the whole electric vehicle to be cheaper than comparable vehicles. This is still,
I think
it's not 15 years away. It's more than 5 years away.
I mean, I think it depends also on the cost of gasoline and petrol. I mean, if artificial,
Yeah.
for some reason, if that shoots up, clearly people are going to look for this, and this becomes inevitable then. I mean, people will have to, who want to move around, will have to use electric vehicles.
Yep. Makes sense.
There's a question from Mr. Jaideep Juneja. For personal vehicles where asset utilization is poor, operational cost is not important. It is capital cost. What's your view on this? Other technologies besides electric for vehicle propulsion that will compete with electric. What's the alternative to cobalt? I think he asked three different questions.
Yeah. So I'm just reading. So for personal vehicles where asset utilization, I think that means vehicle utilization is poor. Operational cost is not important. Yeah. So for that segment, we'll adopt electric vehicles only when electric vehicles are at least the same or cheaper than alternatives. If your daily travel is high, then it makes operational sense to own electric vehicles now. Or you don't much care about the price, you're willing to pay a price premium. That's what you're seeing in the market today. But generally, mass market. I work in the EV industry. I don't own an EV because operationally, economically, doesn't make sense today. I probably will own an EV soon because I probably should, just for the experience of charging and whatnot for my personal benefit. But economically, doesn't make sense still.
I think his second question was other technologies besides electric for vehicle propulsion that will.
Sorry, there are other questions. Hang on, let me read. Other technologies besides electric for vehicle propulsion that's a great question. So Toyota and to some extent Hyundai, Honda, and some extent Hyundai, but Toyota mainly. Toyota, up until very recently, were still heavily in denial of electric vehicles. For the longest period, they have been investing and still continue to do so in fuel cell technologies. General Motors also, over the years, has invested a lot in fuel cell technology. Toyota now has come, let's say, outside. I use these words loosely, of course, but they have an electric vehicle coming. Does not mean that they have let go of their fuel cell aspirations. It's a deeper topic, but high level, this is the crux of it. Fuel cell technologies are likely attractive, unproven, but perhaps where the entry point for fuel cell technologies will happen, it will be on long haul freight, where you have, it's large trucks traveling long distances, where the battery today is still very heavy, and you need to pack a lot of battery cells inside a heavy truck, and makes it very expensive. The power density for hydrogen is much more attractive than lithium-ion batteries. So fuel cells are likely not going to dent the market for passenger vehicles or two-wheelers or three-wheelers in anytime soon. The economic business case for fuel cell vehicles is fundamentally on long-haul freight. That's why in the US, there are a few companies that are investing in fuel cell technologies for long-haul freight. There's a lot of controversy around it also. It's not a resolved problem, but it's further behind electric vehicles.
I think another question from
The third question: what was the alternative to cobalt?
yeah.
I mean, the alternative is right now. So Tesla, for example, has made an announcement already. So Panasonic is their cell provider, and in China, I think it is CATL. They plan to be cobalt free in the near future, next few years. So what is the alternative? Essentially is other chemistry, less reliance on these rare earth metals. That's one. The other piece is solid state batteries. So manganese and phosphorus, etc. There are other chemicals that are being assessed whether specific chemistries will still work. This is an unsolved problem. This is an ongoing R&D activity that will continue for quite some time, years, till and there won't be, today, there isn't an agreed upon chemistry or form factor. So form factor meaning you have cylindrical cells, you have prismatic cells, you have pouch cells. 3 types of cells, and these have different chemistries. There isn't an industry accepted form factor or chemistry that is superior than others, that is well accepted. That does not exist. So this will continue for several years until we reach a steady state, and we're just not there yet.
There is a question from Mr. Mani. With lithium batteries being the dominant battery technology right now, do you think we have enough reserves to support the EV market, especially if it gets global traction? And even if that happens, don't you think there will be a global dependency on China for lithium? I think they are looking at Greenland as an alternative option, but don't you think it's still a big concern to depend on just China?
Yeah, I mean, China is one source of lithium. The good news is lithium can be harvested. You can produce lithium.
Okay.
There's a cost associated with producing lithium, but you can do that. Of course, it's better if you have lithium reserves to source from, and the current lithium reserves are well enough to support the necessary penetration. The supply will be enough. Of course, the market will go up and down. The correct way of framing the argument is, who owns the supply of lithium? Can they create artificial shortage of lithium? And thereby, can the price of lithium fluctuate? The answer to all those questions is yes. That then may hurt electric vehicle penetration. So China has, of course, like always, they've been smart to grab hold of many of the lithium reserves in the world, so that they can, there will be a stage at some point when electric vehicles will be appreciable volume, and there may be artificial shortage of some of these materials. That's why there's another reason why the chemistry is so important, and there are, the optimal chemistry is still undecided. The good news is this is not a problem specific to India. This is a problem for existing countries outside of China, Europe, North America, where there is significant EV penetration already. So by the time there is critical mass in India, there will,
the problem would have been
likely the world will reach a stage where we'll have a better solution for it.
Ms. Disha is asking, is the return on recycling and serviceability into bracket management of afterlife of the EV components going to be higher than the risk of not having a steady state of these components yet?
Make sure I understand the question. Let me read this. Is the return on recycling and serviceability going to be higher than the risk of not having a steady state of these components yet? I'm not quite sure what the second part of the question means. So the risk of not having a steady state of these components.
So I think like you said, the lithium or the cobalt, it is still under research. The battery technology is still under research, so it has not
Yeah.
reached a steady state yet. So there is some R&D dollars being spent on that.
Mhm.
Think the return. I think what she means is return on recycling and serviceability uh, going to be higher than the risk of not having a steady state. So probably the R&D spend on those is it higher than R&D spend on recycling and
Yeah. So maybe I'll break this down. So let's break out the first question. So if I'm an EV battery recycler, am I making a return on my investment? Is it an attractive business proposition for me today? The answer is no, it's not. It's still very much a net negative cost proposition as it stands right now. And see, this is an area where there is tremendous investor money being spent to solve the problem. Of course, there's high risk, high reward kind of business proposition right now for investors. The second part of the question of, I think it means that if a battery were to break down and you were needed to service the battery, how does the cost proposition align there? And absolutely, that equation is still also unsolved. Let's look at indicators. One of the indicators is most of the EV OEMs are providing powertrain warranty that is much higher than conventional vehicle powertrain warranty. So for EVs, it's around 8 years. For conventional vehicles, around 5 years. What that means is they acknowledge there is a risk that there is a cost associated with late life repair of batteries of these vehicles that they don't want to put the burden on the user. So there's a cost associated with it. OEMs will eat that cost right now, but there's a cost. At some point, rubber will meet the road. The cost proposition of the entire life cycle, like I said, it's not solved yet. So no, it's not an attractive business proposition. B, it's not necessarily a complete worry yet for the end user because OEMs are taking the burden for now. So, the burden is essentially once this problem starts becoming mainstream, the residual value of your vehicle starts going down, it starts depreciating more, so on and so forth, and you're left holding the bag, so to speak. So, absolutely, it's a valid concern. But if I didn't understand the question correctly, feel free to rewrite, and I'm happy to answer.
Salil is asking, do you see EV OEMs having proprietary charging infra, like how Apple has in electronics for competitive advantage?
So my opinion on this is there will be a steady state. Let's talk steady state, right? Because right now, we should separate transients from steady state. Transients, yes. Steady state, no. Why no? The charging infrastructure that is created by OEMs. So who created charging infrastructure? Tesla, because they were the earliest company to make electric vehicles, and they realized correctly that unless you have DC fast chargers, then people will always have range anxiety in mind. They won't adopt. So they were compelled to invest in charging infrastructure. It was born out of necessity, not as a business proposition. In steady state, now there are a whole host of charging providers. I work for one, where in steady state, that problem can be better solved by charging providers. It's like OEM and supplier, same equation. The OEM will do what is necessary initially to sell cars. Once you reach steady state, if there are better cost-effective alternatives out there, they will outsource to suppliers. We're reaching that stage for charging infrastructure. It wasn't the case 10 years ago. That's why you did see OEMs, Tesla, putting out their own charging infrastructure. It was out of necessity, not as a business proposition. There are some companies still trying to do that. Again, this is my personal opinion, is in steady state, that will go away. Now, if you have, I'll give an example of some use cases in the US. There are some OEMs who will have their EVs being used for very unique purposes, like off-roading, adventure, things like that. Unique spots where typically charging providers won't install stations because the utilization of those stations is low. In those cases, if those use cases are compelling for the driver to use their EVs to go to that spot, and if they can't use the EV to go to that spot, they won't buy the electric vehicle, they buy a gasoline vehicle. If that becomes a barrier, then the onus is on the OEM to solve that question. Those are a minuscule portion of the entire charging infrastructure problem. So in some cases, you will still see the OEM owning those charging stations. I started the call with essentially explaining owning and operating charging stations is a very expensive value proposition. OEMs don't and will not want to get into that. Charging providers will, because then you get scale across various drivers that are not tied to an OEM. It's the same part. I'm a supplier of engine components. I can sell to 10 different OEMs rather than the OEM manufacturing that same component in the house for 1/10 of the volume. It's a similar question. So in steady state, the OEMs will not own charging infrastructure. This is a temporary problem that will go away in due course.
I think the next question is relevant to what we discussed right now. Is there a standardized charging port on all electric vehicles around right now? If not,
yes.
How does the charging infrastructure cater to all the different EVs on the road?
Yes. Yeah, so there is. As always, there is an exception. Tesla has their own standard. But all Tesla vehicles come with another adapter that is standard in the industry that you can use and charge anywhere. So you can charge at Tesla charger stations, you can charge at other charging stations. Again, steady state, this will be standardized. Like in the automotive industry, you have a standardized quality check process called PPAP in America. It's standard. It's going to be a standard. There is no reason why anybody, an OEM or a charging provider, should have their own charging standard. It just will not make business sense. Forget about the moral sense. It won't make any business sense to own a specific standard. This will be a standardized proposition. But by continent, I should add. So North America has its own, Europe has its own, so on and so forth. Regional differences will be there, but it will be a standard.
Ameya is asking a philosophical question. Are we as a human race concentrating too much on EV, and are there much easily achievable solutions like trains or public transport which can solve the green transportation issue?
Well, the question isn't either or, right? The question never is either or. The question is, the valid argument could be, in what priority should we solve these questions? But again, there isn't a central authority owning this. This is driven by business opportunities. These are for-profit businesses trying to enter a space to make money. Let's be fundamentally clear about this. This is a for-profit entity, and there's nothing morally wrong about it. If there isn't a business opportunity, then there isn't an opportunity. So right now, and this will very quickly resolve itself. Either EVs will be cheaper than gasoline vehicles, or they won't, and will hit a wall, at which point everybody will start backing off. It's all driven from a business opportunity. If there's no business opportunity, there's no smart investors putting money behind this. So if the proof will be in the pudding whether it will pan out or not.
Right. Is there any research going on for charging the EV batteries on road in traveling phase through solar?
The key operating word is in motion, so traveling. The problem specifically here is that the surface area available for a solar panel and how quickly that can translate to power, the equation is not self-sustaining. You can, let's say, marginally improve charges. You can have electrical charging. Again, it goes back to business proposition. The cost required to put something like that on top of a vehicle to then convert it down to charging, this becomes a problem only if you can't reach your destination with a single charge. The correct problem to solve is make the battery smaller, lighter, with more power density, with cheaper, so that you can pack the necessary battery in the car, that you can go the necessary distance. That question will be solved first, and we won't feel the need to have a solar panel or all these any other fancy elements, because the cost proposition for that is not going to line up.
Do you see long-term growth or degrowth in vehicles for personal mobility, irrespective of propulsion technology, keeping in mind technologies for shared mobility, autonomous vehicles, etc.?
Yeah. Great question. Again, the question is, you need to unpack it. It depends which region. For India specifically, yes, personal ownership probably will, in US also, personal ownership likely will go down. The question always is, in relative to what? So you have population growth. Population growth drives increase in increased need of car ownership, and then you have the downside of personal mobility solving for that. So you have one variable causing growth and another variable decreasing growth. So how will those stack up against each other is the question. The forecasts suggest that generally car ownership net will still go up because of population growth, because of commercial needs. So like you have Amazon, for example, home delivery services, you have food delivery services. These are other avenues that are weren't there 10 years ago. So now you have other needs of mobility in the market. It's not personal mobility, but it's commercial mobility. So net you still see, and the metric to look for here is in the US called vehicle miles traveled, VMT. It's the same. The logic is how many kilometers, miles you travel, regardless of how many units, vehicles are necessary to travel those miles. And VMT as a human race is always going up, always.
I think Aditya is asking, when oil dependency goes down for automotive sector, oil producers will likely need to increase oil prices to maintain their profitability, especially since auto sector is one of the major market for oil. This could translate and trickle into increased costs of other normal goods, food, groceries, plastics, etc. Has there been any research done on how this may play out? On one hand, EVs will save costs to end users for operating a car, but they could very well pay higher costs on other goods, which would still be dependent on oil to manufacture them. Wondering if any research is done behind this.
Yeah, research has been done. There's a nuance to the question. The cost of producing oil and how it translates to the end user is a very complex journey, and it depends very much so on the region. So, the cost of production of oil generally is very cheap, considering, US produces a ton of oil. US is very close to the largest producer of oil now, along with Saudi Arabia. The cost of oil production is very cheap. It fundamentally depends on how much the government wants to charge people for the oil. In the US, the government has decided to not tax oil for a very specific reason. Other countries follow different models. I started with Nordic countries. Nordic countries, it's triple the cost to the end user compared to the US. In India, it is also higher. India obviously levies tax on oil before it passes on to the consumer. So it's not a direct economic, kind of one-to-one assessment. The cost of production is very cheap, and if truly, if the industry would work in like cost of production plus specific static margin, goes to the end user. There is no issue. Oil fundamentally as an operating element is very cheap. The question is, what is the role of the government? How much they would tax, on top of it? Will other goods be cheaper or expensive? Again, there are several other variables at play. So now we're getting into macroeconomic territory, where several variables affect the outcome of one. Oil is one of it. If even within oil, there are many complexities. So it's, long story. It's there are studies. If somebody's claiming they know the answer, it's incorrect. Nobody knows the answer. It's a complex question.
We missed.
Thanks for that.
From Mr. Sandeep. India is 15 years behind in the conventional vehicle technology. For example, the implementation of ABS, airbag regulation, autopilot vehicle trial, etc. With that speed, EV in India may require 40-50 years. Is this early call to think about EVs in India?
Yeah, so started off with reshare this to make the point. Hopefully you can see the screen. So yeah, I mean, generally speaking, again, to clarify, this is not a race, but in trajectory, yeah, India is very much lagging behind compared to most of the other major countries. And the reason I kind of outlined the reason at the start of the chat. Fundamentally, one is government subsidies, where China is ahead because of government subsidies, and the other is price of oil, where Nordic nations, there are 50% penetration of new vehicle sales in Sweden, Norway, Denmark, those countries, because price of petrol is very expensive in those countries. So either you need government subsidies, or the price of petrol needs to be ridiculously high for electric vehicles to penetrate. If none of those happen, then electric vehicles are still a long way to go.
Another question was, from a fossil fuel consumption perspective, for generating additional electricity, into bracket for electric plants, manufacturing and end user consumption, how much of an impact it will have?
Sorry, I can't.
It's a question from Aditya Rajderkar. Question 2, from a fossil fuel consumption perspective.
Question 1, question 2. From a fossil fuel consumption perspective, for generating additional electricity for electric plants, manufacturing, end user consumption, how much of an impact it will have? Make sure I understand, Aditya, what you're saying. So
yeah, so what I'm basically trying to understand is, obviously with the increase in the EV market, the manufacturers of electricity, right, along with the electric plants, the electric plants themselves, plus the manufacturers and end users, because obviously people are going to use more electricity to charge their cars, right? So in general, there's probably going to be an increase in the fossil fuel consumption, right? Is that the train of thought? Because the way electric vehicles are being sold, it's being sold as green energy, right? Keeping aside the greenhouse emissions, but from a basic fossil fuel consumption, do we see the increased consumption of fossil fuels because of the EV space?
Yeah, got it. So good question. Let's journey back to one of the comments I made earlier. So let's break this down into 3 buckets. One is cost of producing, let's say vehicle manufacturing, vehicle operations, and end of life use. So vehicle manufacturing, let's leave aside whether it's fossil fuel or renewable energy for a second. I usually try to separate those two. What source of electricity is being used is a very valid question, but let's put this aside for a second. The energy consumed to produce electric vehicles, specifically electric powertrain components, battery and all these others, compared to engine transmission, energy used to produce like for like, yes, it's higher energy necessary to produce electric components, so battery, etc.
Mm-hmm.
The operational cost of how much energy you need to use these vehicles is way low. So it's roughly around a third, ballpark, a third cost effective. In other words, you can go 3x the distance with the same energy consumed. Energy consumed meaning energy used in either petrol or same energy used for electricity. It's kind of, you can go 3x the distance. So to operate electric vehicles, it's much more, much less energy consumed, much more cost effective. The third part of the equation, how much energy is necessary, is still TBD. Generally, the notion is that in steady state, the energy consumed over the life cycle of electric vehicles will be lower. We're not there yet. Now, overlay that with what source we are using for powering manufacturing. Fundamentally, that question is the same, whether you're producing regular cars or electric cars, or using what energy is necessary to produce anything. So the question really isn't about the source of energy. You can solve this energy source question regardless of whether you're using electric vehicles. So let's not confuse the two. The source of energy is absolutely a valid question, needs to be solved irrespective of what type of vehicle you're using. If you do decide to use electric vehicles, generally over time, you'll find that you consume less energy.
Okay, thanks for that.
That's probably where non-conventional energy technology might come in. Potentially, could charging stations use solar energy?
Yeah. So again, the answer is yes, and there are advancements already happening. Again, the question isn't technically whether it's possible. Yeah, technically it's possible. Is it a compelling business case? Not yet. So that's where it still kind of starts falling apart. Things will become steady state when there is an attractive business proposition for the private sector to come in and make money. It's just nothing immoral about it. It's just the
fact of life.
Fact. So just not cost effective right now. But there are applications, by the way. This again goes back to the surface area available for solar energy. So you have solar panels, how much surface area there is to convert. And essentially, you then have, if you have a stack of, let's say, charging stations, one after the other, where it's a DC fast charging arena like Tesla has, for example, in some parts of the US, yes, solar energy comes in and you can charge. It may work, and in some cases it is already being pursued. It works in only a limited number of cases. So the ground reality is DC fast charging is only necessary in about less than 5% of the use cases. So fundamentally, how you operate an electric vehicle is very different than how you operate a petrol vehicle. How is it different? In petrol vehicles, you need to go find petrol to fill up. In electric vehicles, you go find the spot where you would go anyway and charge there as an advantage. And if you think about where the vehicle is parked, for the most part, it's at the home or at the workplace. So usually, where and the range anxiety equation is it's more of a fear in consumers' mind. It's less reality. The infrastructure is not the barrier to solve electric vehicle penetration. DC fast charging, where you run out of energy and you have to find a spot, only occurs in less than 5% of the cases. How does that tie to solar? It essentially, for solar ecosystem to work, it fundamentally would work on DC fast charging, which is really low number of use cases. So you'll see it, but not widespread.
I think with that, we'll conclude today's session. I thank you for your time. I know it was a Sunday morning for you, and being in the US, it was an early Sunday morning for you, but still you managed.
Yeah. I'd rather talk about electric vehicles on a holiday.
But anyways, thank you for your time, and I hope it was a value addition for everybody. and clearly some of my doubts got clarified regarding electric vehicles and their use and their where we are and whether I should buy electric vehicle in the near future or not. Clearly that question was answered.
So, well, I mean, let's be clear. Everybody should buy an electric vehicle. I will buy an electric vehicle. Does it make economic sense yet? No. Whether should you buy it? Yes.
Fine. So thank you for your time, and we'll catch up later.
Yeah. Thanks everyone for attending.
Bye.